Okay, they give us a sequence and they ask us what kind of sequence it is. So let's start with the easiest type and see if it works, right? 7 to 11, that I'm adding 4. 11 to 15, I'm adding 4. And 15 to 19, I'm adding 4. So this makes it an arithmetic sequence, right? And if it didn't work with adding, I would try multiplying, right? All right. Define the sequence explicitly, right? So explicit versus recursive, right? So explicitly is similar to y equals mx plus b, right? So this 7 is the first term. So what we can do is kind of go backwards, right? Backwards by subtracting 4 to find the 0th term, right? The 0th term, which is 3. So now, if it were slope-intercept form, I'm doing b down here, I could write it as the slope, which is 4x, plus the 0th term, which is 3, the imaginary 0th term. But for sequences, we don't use y, we use t of n, because we want the domain to be, right? We want the domain to be positive integers. So we write it as t of n equals 4n plus 3, and this locks the domain to be 1, 2, 3, right? Positive integers. All right. And C says, is 109 a term in the sequence? So what we have to do is we have to see if this comes out to a nice integer value for n, right? So we subtract 3 from both sides, and we get 106 equals 4n, right? And then we divide both sides by 4. So you have to be able to divide 4 into 106, and if you can't do that in your head, you come over here, right? 4 goes into 10 2 times with a remainder of 2. 4 goes into, right, 26 6 times, right? 6 times. 6 times 4 is 24 with a remainder of 2, and then 4 goes into 25 times, so 26.5. 26.5 is not an integer, so that's not going to be a term in the sequence. So the answer would be no, right? It is not a term in the sequence.